All right, well, it's 10 o'clock, so we will get started. Good morning, everybody. Thanks for joining us for another coffee break. I'm Tyler Martin with Long. We've got a cool new product that we're rolling out in the K through 12 market that I've got Mike Davis with IP Video to talk about the Halo sensor. Morning, Mike.
Good morning. Thank you, Tyler. Appreciate that. I'm going to get going with a short presentation here. So this is the Halo 2C. I may also throw in some information at the end about the 3C, which will be out in another month or so. We are the IP Video Corporation, so don't be confused. IP Video, this is a sensor we're talking about, but that's the name of the company. My name is Mike Davis. I'm the National Sales Manager for IP Video, and we'll focus on the Halo 2C today. The company itself is based in Bayshore, New York. So all of our manufacturing, engineering services is based there. So it is a fully made in the USA product, NDA compliant, TA compliant, UL listed. Very important for a lot of reasons. One of the major ones is we do a lot of business in the K-12 market. They're still spending ESSER funding and grant funding on an ongoing basis. And a lot of those are helpful in helping them to get funding. The product itself, Halo 2C, looks like this. If you can see my image there, might be a little bit small, but this device is about 6 inches in diameter. It's meant to be recessed mounted, and all this area here is air intake. So this is a multi-purpose sensor. Very, doesn't look like anything specific from below. There is a little light here. Installation is super easy. We've got a network port here. It is PoE, so just a base 15-watt PoE from here. And we do also have 2 relay inputs here as well. So if we want to communicate with the local alarm panel or access panel or something like that, we can do that there as well. Mounting it into a soft ceiling is super easy. We just got pinch tabs right here. The thing weighs just a couple pounds. We can go into drop ceiling or soft ceilings and easily be installed and connected. If we do have hard ceilings, we do have the ability to use a back box. We can use a conduit here and mount this straight into the back box, bring it down or mount it directly to a harder ceiling as well. Inside Halo, there's a lot going on. We have 12 different sensors and 2 microphones. All of those sensors are collecting data every second. So we're actually collecting about 18 data points from those 12 sensors. That gives us more than 1 million data points per day. So it's a lot of information being captured there. All that data flows into an internal database at the device level, and that data is accessible. So you can use that raw information. So if you want to set your own profiles or notifications, you could do that on any of those sensors. Could be, temperature or humidity or CO2 or ammonia or any of those sensor points. We could set thresholds for above or below or between or trending in one direction or another, and all sorts of different ways to modify that. But you do have access to all that raw information. You can also combine things together. I want to know if CO2 goes above this number and also TVOC goes above that number. And so we can combine things together and create our own profiles that way. That's what we've done also. We've created a number of unique profiles or events within the device. It now comes with 15 different events. We started off just a couple of years ago with 2. We had vape and vape with THC, and now we've got a total of 15, just firmware updates, same hardware for the last version. As this is a good example of vaping. So there are 4 or 5 elements of vaping that we can detect and measure. To build our event profile, we'll go into a lab environment. We'll look at all of those different things that we can detect and measure and build out an algorithm that will show us the relationship from each data point to each other data point. We'll incorporate a time element, so we look at rates of rises and decays as well, and we'll build out this algorithm that has a very accurate way of looking for specific events. vape or vape with THC and so on. Whenever we build these events, we also have thresholds. So these give us the ability to change sensitivities. And when we cross over a threshold, we go into actions and notifications. So locally at the device, we've got an LED light. We can turn that on, off, blink, change colors. We have the ability to play an audible, could be a siren or could be a notification message, could be an audible file you downloaded or recorded on your own. So lots there locally. We've got the two outputs that are relays to connect to. We also have the ability to send emails and text messages directly from the device. We have over 65 different integrations with different VMSs, mass notification, emergency notification systems, and so on. And we can communicate BACnet. So all of those raw sensor values can be communicated, as well as the events can be notified as above or below threshold, or in alarm or not in alarm. When we also collect data from microphones, so that those audible files are just looking for profiles or patterns of audio. We don't flow through the audio, so we don't record it or pass it through in any way. So Halo is always able to go into areas where there are expectations of privacy. So fully capable to go into bathrooms, locker rooms, employee lounges, any of that sort of area too. These are the different profiles that come default with Halo, kind of broken down into some categories here to look at. So environmental, some basics, temperature and humidity and barometric pressure. Tamper, though, is an accelerometer. That's a device looking for any sort of vibrational movement. We can calculate that. We'll report it as a tamper condition. Light, we have a light sensor, so luxometer, we can set light values. Obviously, a lot of ways to use light values. One, and especially in schools, is devices covered up. We can have a lower light threshold there. A lot of chemicals, we can dive deeper into any of these if you'd like, but these are usually the basis for a lot of our other events that we have. And then we've got a lot under air quality. Three terms that we talk about a lot: IAQ, indoor air quality, generic term, as you guys know. AQI, we use air quality index, the EPA standard. We do measure that on an indoor basis, same values and formulas, and give you an indoor AQI. And then we also have health index. Health index is based on 6 environmental conditions that the CDC tells us contribute to the spread of airborne viruses. So we look at that, we aggregate it under health index and let you know where your air quality is in relation to the CDC standard. Vaping. So this is a big one for us. Regular vaping, which also includes anything that would be combusted or smoked, right? So could be a cigarette or anything else that they're smoking, will be caught under that vape profile. We also have vaping with THC, so we can tell you when that vaping signature includes THC. Masking, this is vape masking. We're not looking for mask here. Vape masking is when we are looking at a signature where somebody's spraying an aerosol spray or some other airborne particulate to try to disguise the signature of vaping. So it's masking. We actually have a 4th one coming out next month. That is the smokeless vape. So you might hear about that. There are a lot of new pens coming out from different manufacturers. Philip Morris is kind of leading the way there. There are ones where there's no visible smoke or fumes, and we're able to detect that one too. We just got our patent issued on that. Particulate matter in 1, 2.5, and 10 microns. A lot of different potential relevance there. Under audio, we have a number of audio profiles today. So aggression, we've kind of grouped aggression. We're looking for different patterns of audio that match a pitch pattern and frequency to yelling, screaming, fighting, vandalism. Those sorts of things will show up under aggression. We do have a simple analytic called abnormal noise level. This is just us looking for a decibel range over a period of time. We don't know exactly what's going on, but something you might want to pay attention to. Gunshot are probably our most sophisticated algorithm. We use pitch, pattern, frequency of audio there, and percussion all have to match different known profiles of weapons. We've measured all major calibers of handguns and rifles, and we do have third-party certification on that if that's ever important. Keywords. Keywords are pre-programmed keyword phrases that are designed to be like a verbal panic button. So if we said one of our keyword phrases, the device would go into alarm, and default response is going to be lights flashing, notification messages playing, and our distribution list emailed and text message. So sort of a verbal duress scenario. If I want to interface with Halo one-to-one, the easy way is browser-based. So I can browse straight into an individual device. This is the first thing you'll see. This is a dashboard of one of three. You'll see each of these icons here followed underneath by a description. These are going to be any of your active profiles. So all these are going to be your security. Next row is going to be your environmental. And the blue box is going to be real-time sensor data for each of these individual sensors. We can take this whole box and we can push it to a video surveillance system as an RTSP video stream. So you could watch this dashboard on your monitor somewhere with your other video cameras if you wanted to see that as well. Most of this we covered. Coverage patterns for the device for anything chemical, which is going to include vaping, is 12 by 12, 144 square feet. Anything audible is going to be 40 by 40, and gunshot detection will be 50 by 50. Should have all the right certifications. You know, UL is a must, FCC is a must, Plenum rated to meet fire code in the ceiling. It is also an IK10 rated device, so a bit durable as a vandalism rated device. These are some of our integrations. So there's about 40 on this page. There are about 65 in total that are done. So this is not everything, but you'll get the idea. All major surveillance systems, lots of cloud-based video systems, EMS systems, access control systems, and of course, building automation. We do have BACnet. We do have a number of different things with BACnet now, KMC, Commander, and a few others we've got integrated there. So you'll see a lot of those on our website. We do integrate directly with BACnet. As we mentioned, there's a lot of ways to talk about this. So, you know, we won't do that now, but if you guys would like to know more information, happy to share that or a pick list with you or anything that might be relevant to you guys. System diagram, super easy. So these devices are all autonomous, no control panel needed, no server needed. The devices are going to work individually. We're going to group them in software, but we just need to connect them on your network, get them connected to an email server. Optionally, you can connect them to a time sync server for time synchronization. What other devices we want to share that data with that might be valuable, might be your VMS or BACnet system. If I want to view and manage Halos one at a time, I've got browser-based is going to be your easiest. Multiple at a time, all within the same network. We have a free application called Halo Device Manager. And then cloud-based, that's when we're going to do enterprise level management and reporting. So this is the extra fee here in the cloud. All these other things are one price for the product and the software. And that, I think I made it under my 15 minutes and maybe allowed a few seconds for questions.
Yeah, Mike, do you think you could scroll to our last slide?
Yes, sir.
All right, great. Thanks, Mike. Yeah, it's a really cool product. We're starting to roll it out in a couple of our K through 12 customers here shortly. So reach out to your log rep if you have questions. Thanks for joining us, and hope you guys can tune in next week. Ryan Balski is hosting Daikin Applied on their Precise line. Thanks, everyone.